So the topic we're going to talk about today is one we're going to revisit over and over. We'll talk about it the very first time this time. And then when we have inequalities, our next unit, they'll come back again because it's something we'll have to know about there. And when we have what are called systems of equations, and that will be next year. We'll revisit this topic. So anytime you deal with equations and inequalities of any type, you're going to have three possible outcomes at least. So let's talk about how that relates to what we're doing in equations, okay? So we're going to call this, it's actually the title's a question. How many solutions does an equation have? All right. So go ahead and write that down. So it turns out that when you have a one variable equation, like the type we've been solving, there's three possibilities. So let's write that down. One variable equations have three possible outcomes. One variable equations have three possible outcomes. So let's start with the most common one, the one that happens pretty much every time that we've solved equations up until now. So that's when you have one solution. Okay? One solutions are the most common possibilities. So let's look at a quick example of that. And we've done these time and time again, but we'll put one in our examples here. So here's an example of one that has one solution. 3x equals 5x plus 8. Okay, so it's an equation. It's a math sentence involving one variable, right? And we'll solve it. So let's see here. No distributing. We don't have to combine on either side. We do have variables on both sides though, right? So let's get rid of the 5x. And nothing special happens here. Basically, I get negative 2x equals positive 8. And I divide by negative 2. You get negative 4. And, well, let me write down that answer. X equals negative 4. This is my answer, my solution. And this is only one solution, one answer. In other words, it wasn't x equals negative 4 and it also equals 5 and that equals 16. I didn't get multiple answers. I just got that one answer. This is one solution. Okay? And this is every time we've solved, this is what we've gotten. Now, it's possible that other things might happen. And so the next one is going to be an example when we have no solution. Okay, so I'm going to write it at the top. I should have highlighted here. So this is one solution. And the next one's going to be a no solution. Okay. No answer, exactly. It's an equation that has no number answer. There's no possible answer. Watch and see what happens. So every time you get a no solution, the same thing's going to happen. So let's write it down. 5x plus 2 equals 5x plus 8. Let's do that. Kind of similar to the last one. What do you notice, though? Do you notice something here in the equation? Yeah, that's an important thing to catch on to. 5x on both sides. Yeah, Abraham.
They aren't equal. They're not really equal.
Yeah, and they're not really equal besides that, right? You got a 2 there and an 8 there. Good observations, and they are going to make the difference because based on what we've learned to do, we don't distribute, right? Nothing to distribute. If I look at each side of the equation, I can't combine there. I can't combine there. Yeah.
That make it 2 equals 8.
So, that's why on the I side is 0, right?
Well, let's see what happens.
Y equals 0.
Well, let's see. What do I have on the left side of the equation?
2 and 2.
A 2.
2 plus 8.
Well, 2 on the left side of the equation. You bring down the equal sign. And on the right side, you have 8.
So
This is a statement. It's a math statement. When the variables drop out, like they just did, you're left with a math statement. Now, math statements are either true or false. And we have to decide now if this is a true statement or a false statement. We're saying that 2 equals 8. Does 2 equal 8?
No.
False.
This is false. This is false. So, right, we're going to say this is a false statement. It's not true that 2 equals 8. 2 equals 2 and 8 equals 8. If we had either of those statements, that would be true. My green here just dropped out. This is a false statement. And when you end up with a false statement, our conclusion is, this means therefore in math. Therefore, there's no solution. There's no solution. In other words, we're saying no answer. Okay? No answer here. We ended up with no answer, no solution. There is no number that would work in this equation. I can't go back and pick a number, plop it in, and make it work. Just like here, we got one answer, right? We should probably say that. So that's the second possibility. You end up with no solution. Now, the last one is when you have infinitely many solutions. And we'll talk about what that means, but let's write it right now. Infinitely many solutions.
Isn't that like with the 3x plus 1 thing?
Hold on. Well, what it's going to mean is any real number would be a solution. Any number on the number line would work as an answer. Yes.
Would it be like 5x equals 5x or something like that?
Very close.
No, it's like 3x plus 1. That's
Yeah. What you just told me, Abraham, would be an infinite solution situation. But I'm going to spice it up a little bit. 5x minus 3 equals 5x minus 3. They're identical, aren't they? And if we do what Jasmine suggested previously, get rid of the x's for 5x.
it's going to be negative 3 equals negative 3.
Yeah. We end up with negative 3 equals negative 3, which is another math statement. And it's either true or false. Is it true that negative 3 equals negative 3? It's true. So this time it's a true statement. Whenever you have, this is called the reflexive property in mathematics. You have the same thing on both sides of the equal sign. Okay? So this is a true statement. So therefore, infinite solutions. I get to use my favorite symbol, the lazy 8. Infinite. You guys know about the infinity symbol, right? Infinite solutions. Sometimes they won't call it that. They'll call it an identity. It means the same thing. And what this means is every single number is a solution. Every single number is a solution. Jasmine.
Like in an Excel, there's no solution. What would you put? What would they give it to you?
I think they would give you that possibility. I think they're just going to ask, is there one solution, no solution, or infinitely many solutions? Or identity. They might say identity. That means this. So going back to this, it means every number is a solution. Every number on the number line. Because next year, we're going to briefly talk about and learn some things about numbers that aren't on the number line. They're called imaginary numbers. So what we say is every row number is a solution. Give me a number, plug it in for x, and it could be a positive, a negative, it could be a decimal, repeating decimal. Any number you could think of that exists on the number line, put it in for x, it works. Okay? So that's the key. We got to know when to recognize these. You got to know when we have one solution, no solution, or infinitely many. Oops. Didn't mean to cross that over. Okay, I see a few people still finishing writing this up. So I'm going to give you a few examples here. And see if you can figure out what to do or what we have. So this is what we're going to figure out. How many solutions are there? How many solutions are there? Jasmine, close that up right now. How many solutions are there? Okay. And sometimes you'll tell right away. See if you can challenge yourself. See if you can do that. 9C minus 1 equals negative 1 plus 9c. Infinite. That was quick. Okay, tell me what told you it's going to be infinite. There's some keys there. Hey.
Each side of the problem is exactly identical.
Yeah, pretty much. If you think about it, each side's identical. Gabriel?
I forgot what the property is called. Is it the community property where
Mm-hmm.
like if you flip it, it's still gonna be the same answer?
Yeah.
So,
Yeah. They're identical if you think of the commutative property. 9c minus 1 is, and what's going to happen is eventually you would do this, right? And you end up with negative 1 equals negative 1, which is true. Therefore, infinite solutions. Okay, that was our key there. Let's try another one. Number 2. 2 minus 4x equals negative 3 minus 4x. No solution. We both have, they're almost identical, except on one side you have a 2, on the other side you have a negative 3. These terms would cancel, right? And you'd be left with 2 equals negative 3, which is false. Therefore, no solution. Now, on today's assignment, they're not going to ask you for the solution. They're not saying, what is the solution? You just have to recognize, is there one, none, or infinite? Right? So, once you get to this point in an equation, write down this one. Negative 1 plus 7n equals negative 1 plus 5n. One solution. How do we know it's one solution? There's something specific. Yes?
When you look at what has a variable, it doesn't have the numbers aren't the same, and it doesn't have.
Okay, the coefficients there aren't the same?
And when you end up taking away the coefficient, you still end up with a 2n.
Okay, you still end up with something, right? So, you see the coefficients. We don't care too much about the constants, the minus ones. Yes, they're the same. We got to focus in on the variables. And look at the coefficients. Are the coefficients the same? No, one's 7, one's 5. If the coefficients are different, then you'll have one solution. Because look what we would do for our next step. Well, we don't know what the variable is going to be in until we do this step. Do you see that now that I remove the variable from the right side, I still have a variable on the left? Once you get to this point, you know that there's one solution. Because, yeah, it's going to be 0. And that's a good point that it is 0, because a lot of people say, I see a lot of people do this. Okay, they solve it perfectly. They get 2n equals 0. Divide by 2. And like Gabriel said, 0 divided by 2 is 0. You end up with n equals 0. And then they say, oh, that's a no solution. That's not what it means. That's a one solution. 0 is an answer. 0 is a valid answer. If you end up with x equals 0, j equals 0, whatever variable. If you end up with that variable equaling 0,
It's still an answer.
it's still an answer. And that's one solution.
Because at least, like, you have an idea what the actually is.
Yeah, since you got an answer, even 0, you say one solution. Okay? All right, Jasmine, I want you to try this one. Close the Chromebook. So this will be the last one. Make sure you put down that even if you get 0, that's a solution. Okay? And I'm going to write down this equation. This was number 3. This will be the last one, number 4. I'll put it down. And here it is, negative 9, parentheses, 5x minus 3. So this one's going to have all the bells and whistles, equals negative 26x plus 27 minus 19x. Okay. So let's go ahead and try solving this. What's our first move? Yes, if we can distribute, let's do that. Negative 9 and 5 is negative 45. Negative 9 and minus 3 is positive 27. Okay, guys. I'm going to do something. I'm going to combine my like terms here and bring it down. Is that okay? Kind of save a step?
It does, like, a lot.
Okay. So if I combine negative 26 and negative 19, that's negative.
Plus 27 is infinite.
Yeah, that's what I get. At this point, you notice identical things on both sides. The variables will cancel out because we would add 45x on both sides. So therefore, we say there's infinite solutions. This is true. Therefore, infinite solutions. Or it's also known as an identity. Okay? So today's IXL will involve you recognizing what you have. One solution, no solutions, or infinite solutions.